Hello dear students, welcome back again to Chinmoy's Biology channel. So this is part 4 of matter in our surroundings. Sublimation we are going to discuss today. So today our topic is sublimation and evaporation. So let's get started without any delay. So what are the learning objectives of today's lesson? Today we are going to learn about sublimation. We are going to learn about the effects of changes of pressure. What is evaporation? What are the main factors which are affecting our evaporation process and how evaporation causes cooling. So these all are the important things which we are going to discuss today. So hope you are going to like my episode. So please do subscribe to my channel to stay tuned, stay updated with all the episodes, all the videos which I am posting as per your CBSE curriculum, and I am trying to teach it in a lucid manner and with all the notes which you need for your exam. So stay tuned, stay updated, and let's get started with today's episode. So today we are going to start with the topic of sublimation, right? So yesterday we have spoken about the states of matter, the solid, the liquid and the gaseous state, their properties, and we have also spoken about the latent heat of vaporization. So what is latent heat? We have already spoken, and we have already spoken about the Celsius and the Kelvin scales. So if you have not gone through that episode, first go through it, then it will be easier for you to understand today's sublimation topic. So let's start today with the activity like take a camphor in a china dish. We are crushing and taking the camphor in this china dish, and we are placing an inverted funnel on top of that. We are plugging cotton on the top of the inverted funnel so that the air should not get out from the funnel, and now it's being heated slowly by Bunsen burner. So what is happening here? Let us see the change of state directly from solid to gas. So it is changing from solid directly to gas without changing into liquid state is called sublimation. So what is sublimation? If they give you to define sublimation, sublimation is a change of state directly from solid to gas without changing into liquid state is called sublimation. Now next comes deposition. We can see on the sides of the funnel something has been deposited. So the gas which has been released from camphor, or being converted to the gas, which then converts to solid without changing to liquid form, is called deposition. Is it clear? So the gas, after heating this camphor, it was being converted to gas. This gas again being cooled, it's get deposited on the side of the funnel. So this conversion of gas directly to solid without being conversion into liquid is called deposition. Okay, is it clear to everyone? So any doubts, any queries, please write in my comment box. Now I would start with the effect of change of pressure. Okay. So we have already learned that the difference of various states of matter is due to the difference of the distances between the constituent particles. Now what will happen when we start putting pressure and compress a gas? So what will happen if we are starting to compress a gas? Now enclosed in a cylinder, will the particles come closer? Do you think that increasing or decreasing the pressure can change the matter? So here you can see it's a piston. This is a cylinder. We started compressing. So by applying pressure, the particles can be brought very close together. So these are the particles of gas. They are being compressed. So compressed so much that in the last part we can see that they are highly compressible. So applying pressure and reducing the temperature can easily liquefy the gases. So is it clear? You are applying pressure, you are reducing the temperature, and it can gradually liquefy the gases. So we know that under high pressure we are using LPG or liquid petroleum gas for our cooking purpose. Okay. Now, have you heard of solid carbon dioxide? Yes, we have heard of this because if it is stored under high pressure, solid carbon dioxide gets directly into gaseous state, and on decrease of the pressure to the atmosphere without coming into liquid state. So this is also known as dry ice. Now generally for preserving ice creams and all, dry ice has been used throughout many years. So they have been used because it is a hassle-free thing that ice doesn't get converted to liquid. It gradually, when it is in normal temperature, gradually when it is heated, it is directly converted to gas. Okay, thus we can say that the pressure and temperature determine the state of a substance, whether it will be a solid, liquid or a gas. Is it clear? Now let us move on to the next one. Now here we are dealing with the interconversion of three states of matter. So just a flow diagram they have given. So suppose this is solid. Solid, when heated, it is converted to liquid, and this is called fusion. Liquid, again for solidification, when it is converted to solid, it is called solidification. Liquid, when heated, it converts to vapor or vaporization, and gas, when condensed or cooled, it is called condensation. So these are the different processes which are involved in the different states of matter. Then solid, when heated and directly converts to gas, is called sublimation, whereas gas, when without having any liquid state, when converts to solid, is called deposition. Okay, so these are all the terms, very important terms. What is fusion, what is solidification, vaporization, condensation, sublimation and deposition, I have discussed all in details. Okay, is it clear? Now we are going to discuss a few questions. I think you all will know the answer. So first write it, and then if you are having any doubts, ask me in the next comment box. Now convert the following temperature to Celsius scale: 300 degree Kelvin, 573 degree Kelvin. You know that what is the difference between 1 Celsius and the Kelvin scale. So do it as I have taught you in the previous class. So what is the physical state of water at 250 degrees centigrade? So you just need to know the boiling point of water, what is at what point it vaporizes and all. So for any substance, why does the temperature remain constant during the change of state? So this is very important, and I have told you, discussed about the latent heat, right? So with that only you should discuss this answer. So write it first. If you are not getting it, then again ask me. Suggest a method to liquefy the atmospheric gases. So these all we have already taught. Now there was a question in the few questions are there which are very important, so I'll be discussing each and every question in the next video. So you need to subscribe to get the answers of those important questions, that why ice floats on water. So we know that solids are though their density is more than that of liquid, why does ice float on water? So it's having a huge lot of explanation which I'll be discussing in the next video. So let us start with evaporation now. So we all know that we need heat to change heat or change pressure or change the state of matter. So can you quote some examples from everyday life where change of state from liquid to vapor takes place without the liquid reaching the boiling point? So without reaching boiling point, we should think that it has turned to vapor without reaching the boiling point. Now water, when left uncovered, slowly changes to vapor. So if you are keeping a water in, now it is a month of summer, so it's too hot outside. So if you keep a pot of water outside for a few days, they will evaporate, water will evaporate. Wet clothes you give on the outside to dry, they'll dry up. So this is water is evaporating. These two are the main examples how water evaporates without reaching the boiling point. Now we know that particles of matter are always moving and never at rest. So at given temperature in any gas, liquid or solid, there are particles with different amounts of kinetic energy, right? So we told that the kinetic energy increases when we heat a substance. So in the case of liquids, a small fraction of particles at the surface having higher kinetic energy is able to break away the forces of attraction of the other particles and get converted to vapor. So this we have already told when we were discussing about the liquid and the gaseous state. We have told that the kinetic energy, higher the kinetic energy, it is allowing it to break free the forces of attraction of the other particles and getting it converted to vapor, right? So this phenomena of the change of liquid into vapors at any temperature below boiling point is called evaporation. So when it reaches the boiling point, it is boiling, it is not evaporation. So this phenomena of change of liquid into vapor at any temperature below the boiling point is called evaporation. So this is evaporation. So now we will be dealing with the factors of evaporation in the next slide. So now we are going to discuss about the factors affecting evaporation. So what are the factors affecting evaporation? Again, we are going to understand with an activity. So take 5 ml of water in a test tube. Keep it near the window or under a fan. Take 5 ml of water in an open china dish and keep it near a window or a fan. And take 5 ml of water in an open china dish, and you can keep it inside the cupboard or on a shelf or in your class. So record the temperature, record the time on the number of days taken for the evaporation process in the above cases. So you are repeating this experiment on rainy day also, and we are recording several observations. So what do you observe? So you observe actually that the rate of evaporation increases with the increase in surface area. So the surface area is very important. So in test tube, the surface area exposed to air, exposed to sunlight was less, whereas in a china dish it is more surface areas exposed. So the evaporation will be faster in that. So if the surface area is increased, the rate of evaporation increases. For example, while putting clothes for drying up, we spread them out so that it dries up faster. Now increase in temperature. With the increase in temperature, more number of particles get enough kinetic energy to go into the vapor state. So it is clear. Now as the temperature increases, we told that there is an increase of kinetic energy, and which helps the liquid to get converted into the vapor state. Now then comes a decrease in humidity. Humidity is the amount of water vapor present in air. So the air around us cannot hold more than a definite amount of water vapor at a given temperature, right? So if the amount of water in the air is already high, the rate of evaporation decreases. So during rainy season, the evaporation rate decreases, and the clothes take a longer time to dry as the air is with a huge amount of water vapor only. Okay, so more the humidity in the atmosphere, it decreases the rate of evaporation. Now an increase in wind speed. It is a very common observation that clothes dry up faster on a windy day. So while the increase in wind speed, the particles of water vapor move away with wind and decreasing the amount of water vapor in the surrounding, right? So the rate of evaporation increases. So now we are going to deal with how does the evaporation cause cooling. So in an open vessel, the liquid keeps on evaporating. The particles of the liquid absorb energy from the surrounding to regain the energy level lost. And during evaporation, this absorption of energy from the surroundings make the surrounding cold. So what is happening? The particles of liquid, they are absorbing the energy from the surrounding. So as the energy from the surrounding is being absorbed by the particles, so the surroundings are gradually becoming cold. So evaporation leads to cooling also. So what happens when you pour some acetone or nail polish remover in your palm? So what do you feel? You will feel that the hand has become cool. The particles gain energy from our palm or the surroundings and evaporate gradually. So our hand feels cool. So this is a very common experiment. When you put a nail polish remover in your hand, you will see that it is taking the energy from your palm or from the surroundings to evaporate, causing the palm to feel cool. So after a hot sunny day, people, they sprinkle water on the rooftop so that the roof or the open ground where they are sprinkling water, because the large latent heat of vaporization of water helps to cool the hot surface, right? So this is very important, that the large latent heat of vaporization which is being absorbed from the surrounding helps to cool the hot surface. So can you cite some more examples from daily life where you can feel the effect of cooling due to evaporation? So there are many examples, or from daily life events you can think. So one of the example is that why should we wear cotton clothes in summer? So this is another important thing why we should wear, because we perspire more because of the mechanism of our body which keeps us cool. So we know that during evaporation, the particles at the surface of the liquid, they are gaining energy. So the liquid in our body is what? It is the sweat. So when we are sweating a lot, the liquid is gaining energy from the body surface or from the surroundings to change it into vapor. So it is sweating, the liquid is coming out of our body, it is gaining energy from the body surface or from the surroundings to convert it into vapor, and the heat energy is equal to the latent heat of vaporization is absorbed from the body, leaving the body cool. Okay, so cotton being a good absorber of water, cotton absorbs more water, helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. So it is very good question, and it is a very important question for your exam, that why we should wear cotton clothes in our summer. So cotton absorbs the heat, water helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. So is it clear to everyone? Now we will move on to the next important question. Let us see what is there. So why do we see water droplets on the outer surface of the glass containing ice cold water? So same thing. Let us take some ice cold water in a tumbler or a glass. We will soon see water droplets on the outer surface of the tumbler. Why? The water vapor present in the air on cooling or coming in contact with the cold glass of water, what is this happening? It is losing energy and it is getting converted to liquid. So the air in the atmosphere, the air in the surrounding, when it is coming in contact with the glass containing ice, it's being condensed, it's being cooled, and so it's converted to liquid state, which we see as water droplets. So is it clear? So it loses the energy, gets converted to liquid state, and which we see as water droplets. So now we are going to discuss with a few questions. I think I have discussed, or I have explained you all the reasons, and you can explain all these answers with logical reasoning only. So these are very important questions. If you are finding it difficult, if you are not getting any of these questions, ask me in my comment box. I will get back to you with the answers. So let's discuss the questions first. So why does a desert cooler cool better on a hot dry day? Now, how does the water kept in an earthen pot or matka become cool during summer? Why does our palm feel cold when we put some acetone, petrol or perfume on it? Just now I have discussed with you, right? So these are all being discussed in your class. Now, why we are able to sip hot tea or milk faster from a saucer rather than a cup? What type of clothes should we wear in summer? So just now we have discussed we should wear summer clothes, cotton clothes in summer. So all questions mostly has been discussed in your class itself. So try to answer this question, take an answer book and answer. So if you are having any doubts, please do subscribe to my channel. Don't forget to like and share my videos so that all your friends, all your known person can get the benefit from my videos. Any queries, any doubts, write in my comment box. Seeing you soon. Till then, subscribe, stay tuned, stay updated and keep on learning from my videos. Thank you.